Okay, so the last question of this test part, okay? Follow me, yeah. Question B1, subheading 3. Look on your text, page 34. Okay, fine. So as we have been doing the previous two, let us start. Okay, let P of x be the given polynomial, quadratic polynomial, 6x squared minus 3 minus 7x, right? As we have been saying here, now it is important that we arrange this in descending order of the powers of x. So x squared term, 6x squared, which is the x squared term in the first place, and the x term is not in the second place, so we bring it there. And then minus 3, which has no x squared and x, should go to the third place. That way we can now figure out the coefficients of x squared, x, and the constant term. So here a, which is the coefficient of x squared, is plus 6. B, which is the coefficient of x, is minus 7. C, which is the third term, the constant term, is minus 3. Right, having done that, now we know that for any 0, that means for any value of x here, right, P of x is always equal to 0. So that means we can write P of x, which is this, same, can be replaced by this expression 6x squared minus 7x minus 3 equal to 0. Now, the first part of the question says find the zeros, means find the values, the two values of x. And we have been doing usually by factorization. So in order to factorize this polynomial, we multiply the first and the third term, plus into minus, and 6 3s are 18. So when we multiply the first and the third term, the product is minus 18. Then we write the middle term, which is minus 7x. Without the x, we can write minus 7 at the top. And we'll find the factors of this 18. For example, 9 2s are 18. So 9 and 2 are factors of 18. Appropriate factors of 18 that will match up on addition or subtraction, minus 7. This is minus 7, bigger one, minus 9 minus, and smaller plus 2. That way, bigger one we put up and smaller one down. We know minus plus means subtraction, so 9 minus 2 is 7. Bigger absolute value has minus sign, so here minus. So on subtracting minus 9 plus 2, we are exactly getting the middle term minus 7, matching in absolute value 7, and even the sign is minus. Then on multiplying, minus into plus minus, 9 2s are so minus 18. On multiplying, we are getting minus 18. On subtraction, in this case, because it's minus and plus, we are getting exactly the middle term, matching in sign and also absolute value. So those two conditions are satisfied. So this is the correct manner in which we are supposed to split this middle term minus 7. So we'll write here 6x squared and minus 7x can be split into minus 9x plus 2x. You can see here. So minus 7 split into these two, and this untouched, so minus 3 equal to 0. Then we take the highest common factor for 6x squared and 9x. For that, you take the numbers and go to the smaller. The proper way to find the HCF, highest common factor. 6 doesn't go with 9, so you have to go down. 5 also doesn't go with either of the two, so go down. 4 also doesn't go with any of these two. Go down, still not getting 3. 3 is going with both. So the first number, as you go down from the smaller of the two, 6, as you go down 5, 4, 3. 3 is the first number that goes with both these, meaning 3 2s are 6, 3 3s are 9. So that is called the highest common factor. X squared and x common factor highest is x. So 3x into 2x will give you 6x squared. 3 2s are 6, x into x squared. And plus into minus, matching this minus, 3 3s are 9. X is already out, so 3x into 3 is 9x. That's done. Next is a plus, so we write plus. 2 and 3 highest common factor, take the smaller one, just like it took 6 smaller than 9. Here 2 is smaller than 3, so 2. But the problem is 2 doesn't go with 3, so we have to go down. So below 2 is obviously 1. And x is here, not here, so 1 is the highest common factor for 2x and 3. So 1 into 2x is 2x. And plus into minus is minus. Then 1 into 3 is 3, equal to 0. Then next step, we see these two terms, and the common factor is here, 2x minus 3. Here also 2x minus 3. So clearly the common factor of these two terms is 2x minus 3. Take a bracket, and so 2x minus 3 has gone out of this bracket. So inside this bracket will be, first one, 3x. And 2x minus 3 has gone out, so inside this bracket would be plus 1 equal to 0. So this step, it is reading 2x minus 3 into 3x plus 1. So it has been factorized into these two factors. So this is called factorization. Finding the zeros by factorization means finding the values of x by factorization method, which requires us to split the middle term into proper factors, which on addition or subtraction yields the middle term matching in sign as well as absolute value, and on multiplying exactly matching the product of the first and the third term of the quadratic polynomial in sign, plus or minus, and also absolute value. Okay, just summarizing there. So either here 2x minus 3, the first factor will be equal to 0. That gives you 2x would be equal to minus 3 shifted to right side and plus 3. So x would be equal to 3 by 2. First answer. Or you can also say second factor 3x plus 1 equal to 0. That way you write the term containing x alone and shift this plus 1 to right side, and it will become minus 1. So x would be equal to minus 1, and 3 into shifted to right side becomes 1 by 3. So minus 1 by 3. So here the two zeros are 3 by 2 and minus 1 by 3. Yes, exactly matching the book answer. So we write here, therefore, the required zeros, or we can just write it here. We won't be needing anymore this one, so just write for here. After getting these two values below this step, the required zeros are, first one, zeros means values of x 3 by 2, and next one minus 1 by 3. So now the question is saying find the zeros, so we have done that. But the second part of the question says verify the relationships between the zeros that we got here, 3 by 2 and minus 1 by 3, and the coefficients. So how do we do that? We have been doing that. That we verify in terms of this sum of roots, sum of zeros first. So you write here. Verification means proving that our answer is right. So we're going to try to show that these two answers are correct by in terms of sum of zeros. So you write your sum of zeros and you use the roots, the zeros directly. First 0 is 3 by 2. The word sum means plus, and here minus 1 by 3. So that way you're going to get 3 by 2 and plus and minus 1 by 3. That way we get this bracket removed here, these two brackets. So here 2 3s are 6 LCM of the denominators, and 2 3s are 6, then multiply the 3 to the numerator, 3 3s are 9 minus 3 2s are 6, so 2 multiply numerator, 2 1s are 2, and so 9 minus 2 is plus 7 by 6. So the sum of zeros by using the actual zeros is plus 7 by 6, as we can see here. Let us put this one as equation number 1. And then in terms of the actual roots, sum of zeros. The right side here, this one. In terms of coefficients, verify the relationship between the zeros, this by using zeros, with the coefficients. So we're going to have to use this side of right side here. So minus coefficient of x by coefficient of x square equal to, formula is here, minus b by a. So we can do it directly here, I think, minus b by a. So that is minus bracket. B is here, you go up now. So in terms of coefficients, means this a, b, and c are the coefficients. A coefficient of x square, b coefficient of x, and c the constant term. So minus, and b is minus 7, so you write there minus 7 by a, as you can see here, is 6, so you write there 6. So that will give you equal to minus and minus plus 7 by 6. So this is equation number 2. So we can clearly see using equations 1 and 2, we are getting, or we get clearly here, sum of zeros, sum of zeros. Write this and write this one, keep some given, coefficient of x, or rather minus is there, so I write the minus coefficient of x by coefficient of x square. Now let us look here. Sum of zeros in equation 1 is plus 7 by 6, this one. And in equation 2, this one here, coefficient minus coefficient of x by coefficient of x square, is also plus 7 by 6, same equation 2. So these two are equal. That means the value of the zeros 3 by 2 and minus 1 by 3 are correct when we verify it in terms of sum of zeros with the coefficients of x, in terms of coefficients of x and coefficients of x square. Okay. So, but then we have to validate it or verify it in terms of product also. So let's go there. So let's write here. Next, product of the zeros. Product of the zeros is first zero, use the actual zeros, plus 3 by 2 into minus 1 by second zero. So we can clearly see we can cancel this 3 and 3 up and down. So we're going to get plus and minus, minus 1 left divided by down here 2. So let's put this one as equation number 3. And then on the right side is in terms of the coefficients here. So that is constant term divided by coefficient of x square. So we write here coefficient of x square. This one equal to formula here, c by a. So that will be c. We are using now c here, constant term, minus 3 divided by a here, 6. So you write there 6 carefully, then 3 1s are 3, 3 2s are 6. So that is going to be minus, is still left 1 by 2. So let's put this one as equation number 4. So in terms of product of zeros with its right side, constant term by coefficient of x square, also they are equal, minus 1 by 2, minus 1 by 2. So you can finally write here using equations 3 and 4, we get, okay, we get here this one, product of the roots. Let's write that. Just remember this, I'm going to wrap out this one. And then here, this one we have got here, constant term by coefficient of x squared, as you can see, is equal to minus 1 by 2. And product of roots also minus 1 by 2 from equation 3 and 4. So these two are equal. So since we were able to prove product of the zeros is equal to constant term by coefficient of x squared, that again proves or validates or verifies that the answer 3 by 2 and minus 1 by 3 are correct zeros. Correct this one, please. This is not wrong, but this chapter is using zeros. Product of the zeros. Okay, so that concludes this part, and hence, since this answer 3 by 2 and minus 1 by 3, 1 by 3 minus 1 by 3 are verified in terms of sum of roots, sum of zeros as well as product of zeros, we have verified. So you can just write here at the end, towards the right hand corner maybe, right? Hence verified. That completes the part for test 2.2a. I hope you got it right. Okay.